Groundwater salinization is a major threat to California's Central Valley aquifer system. The Central Valley is a very productive agricultural region responsible for producing a quarter of our food in the United States. The fertile soils and good weather make it a great place for farming, except for one problem. There's not enough rain to maintain all of the crops the area is capable of supporting. Because of this, farmers in the Central Valley rely on irrigation to supply their crops with the water they need. All of that irrigation is great for productivity, but it raises questions about potentially negative environmental consequences. Among other issues, irrigation is known to cause what's called soil and groundwater salinization. This is when small particles like dissolved minerals build up underground and make the water stored in the soil and rock too salty for plants and people. My work here at UC Davis is focused on how significant this problem might be in the future, depending on how we address it today. The team that I work with is building a computer model that simulates how much salt could potentially build up in the subsurface based on our activities on land. A question that remains unanswered is whether the natural processes inside the soil and rock will impact salinization, and if so, how much? For the first part of my work, I identified the predictors of salinity across the Central Valley. We learned that salinity is influenced the most by the original chemical composition of the water that seeps into the ground and the type of rock the water interacts with. Both of these factors have to do with how many new dissolved minerals the water can take on and how easily those minerals might find themselves dissolved. Another factor that influences salinity is the coarseness of the soil and rock, which influences how much solid surface area there is for the water to chemically react with the sediments, and also how far the water flows. The longer the water's in the ground, the more time it has to react with the soil and rock and become saltier. Using this information, the next phase of my work is to build a map of the Central Valley that takes all of these factors into account. The map will show how salty the soil and groundwater may have been at any given place before the rise of irrigation. In modeling, we call that information an initial condition. It gives us a baseline to start with and build our model off of. I'm also using my initial work to estimate how quickly these chemical reactions take place underground across the Central Valley. To do this, I'm using geostatistical tools like chemical mapping and kriging, as well as other statistical tools like regression analysis and factor analysis. Those results may be integrated into the model so that when it does its calculations, it does so not only according to our activities on land, but the natural processes happening below our feet. In doing this work, we hope that farmers and policymakers alike will be more empowered to make decisions that will allow the Central Valley to thrive for years to come.